you're here because you want to learn Python, you already know Python, you just want to hear somebody talk about Python and just kind of hopefully absorb something, have fun with it, tell me I'm wrong. I don't care. Let's participate, talk. But let's talk a little bit about where Python comes from and why we even use it, and so on. Oh, here's a bit for you. Who can tell me what computer science is?
Study computation.
Oh, well, there you go. It is, yeah. How come you're not in my class? Indeed. All right, so it is the study of computation. But I do like this big quote, right, by this guy here, Michael Fellows and Ian Parberry. So what would we like our children, the general public of the future, to learn about computer science in schools? We need to do away with the myth that computer science is about computers. Computer science is no more about computers than astronomy is about telescopes, biology about microscopes, or chemistry about beakers and test tubes. Science is not about tools, it's about how we use them and what we find out when we do. And I also come from an astronomy background, so to me this quote is doubly sensible. Like, yeah, computer science isn't just about computers. That's IT. It's information technology in general, right? Computer science is the study of computation. And this is not something I'm going to cover in this talk today. We're talking about computer programming, which is a tool that facilitates computer science. And yes, astronomy is not just about telescopes. There's a whole lot of astronomy without telescopes involved. So we're going to talk about how we can use programming to study the feasibility, structure, expression, mechanization of the methodical processes or algorithms that underlie the acquisition, representation, processing, storage, communication of, and access to information. Always remember that computer science is really fundamentally about algorithms and data structures. That's really the two big pillars that make that up. And computer programming is a big part of how that works. The art of programming is the art of organizing complexity, of mastering multitude, and avoiding its bastard chaos as effectively as possible. I truly believe this quote. This quote really means a lot. And this is Dijkstra, famous computer scientist. But anyways, we don't need to worry too much about all these introductory slides. I do like some of the high points, like programming isn't problem solving. It's teaching somebody else how to solve the problem. Now we get to the point now where AI sort of solves the problems on its own, sort of a bootstrap mechanism. But traditionally, programming is about instructing the computer how to do things. Kind of like a recipe doesn't solve your problem of having dinner ready to eat in the evening. You have to use the recipe to act on it. Usually I show a clip from War Games, or whatever, 1980, whatever, great movie. I'll skip that because we don't have a whole lot of time, but feel free to watch it. It's the clip where they use tic-tac-toe to cause Whopper to go kaput. Hey, so Python is used everywhere. I mean, since I started this course, Python became more and more popular. It's been popular in my circles easily over 20 years. All sorts of very cool applications to it: data science, software engineering, medical, et cetera, et cetera. You should be using Python 3. Python 3.11 is the current release. I would not use anything older than 3.9. I think 3.8 is near end of life this year. Not that it's a bad thing if you do, but just in case. And there are always incremental improvements in those. What do they call those? I think they call that the minor version. I think they might have a slightly different name. But Python 3.10 and 3.11 have some neat improvements that I do recommend taking advantage of by installing them, particularly 3.11. Those of you who used Python before may have noticed that when you get an exception on a very long and complicated line, it doesn't tell you where in that very long and complicated line things broke. 3.10 or 11, I forget which one exactly. Now we'll tell you, we'll look here and say, it broke here. So it's a great improvement for usability, especially for the, teaching and, people like anybody, myself included, like I want to know where it broke. You'll tell me. How to install it? Well, that any number of ways. If you are Linux, likely you have multiple versions in your repositories, whether it's Ubuntu, Debian, or Red Hat based, Yum, apt, whatever, Pacman. If you know those words, you know how to use them out already. So you can probably find how to install that. On the Mac, you have a variety of different ways to install Python. Apple includes a copy of Python already installed. I believe currently in Ventura, Ace Ventura, what is it? Yeah, just Ventura. It's Python 3.9, I believe, is the most recent version. However, you can use a variety of different tools to install other versions. So this is my Eclipse research stuff. By the way, we have a huge eclipse coming up next year. Don't miss it. It's be hard to miss it when it goes dark for 5 minutes. Right. Let me bring up, not that. Hello. Now, I recommend for the easiest way to get started, brew.sh. On the Mac is Homebrew. It's a package manager. Acts like any package manager you've seen before. So you can install any number of versions of Python that way. A more platform agnostic thing is ASDF, or perhaps PyEnvy, which is a plugin. Well, it's separate, but ASDF uses it as a plugin. It's a great way to download and install multiple versions of any number of tools, Python included. So if I needed to install Python 3, 8, 9, 10, and 11 side by side, this could do it for me, keep them nicely compartmentalized, and won't cause any problems and cross over each other. So I use this for managing multiple versions. And it's not just for Python, as I said. You can install like Ruby, you can install Rust, toolchain stuff, and a bunch of stuff like that. Am I doing the time? Yeah, 7 minutes, not too bad. So introduction, continuing on. Anybody know what the universal machine is? Turing machines? Alan Turing? He's the father of computer science. Yeah, he's.
Sorry.
The tape and the symbols and halting problem and all that stuff.
I've actually never learned what a Turing machine is.
It's basically his first modeling of the computer, instructions and basically a tape. You can go back and forth on it, and it's yeah. But talk for another day, I guess. I don't know, but it's basically him modeling the modern fundamentals of the computer with this foundational paper, which I tried to read. It's pretty dense, and I didn't get very far with it. But it's one of the hardest courses I took because it's the most abstract when I was a CS undergrad. Oh, you know what a computer program is. Anybody here is brand new to programming? Flat out no? Oh, I'm sorry.
I learned what a while loop is last week. It was great.
Oh, wait till while loops and for loops. Oh, that's exciting. I'm glad. Wait till you learn about comprehensions. Those are pretty cool too. They're kind of like loops.
Ooh, that's a new word.
What we got? Nick, you are new. Wonderful. So the programming entirely.
Yeah, he's been helping me, but that's about it.
Okay, wonderful. Okay, welcome. Well, a computer program is a step-by-step. You know what a program is already. Yeah. I still have not seen this movie, even though it's been in my slides for years. Still really want to watch it. That's the Imitation Game. Talks about Alan Turing and his fundamental role in breaking the Enigma encryption, German encryption. Let's see here. Software rules the hardware. right? The hardware just does what the software is instructing it to do. And that's the beautiful part about hardware being a universal machine. You notice that with changing instructions, you can tell this static piece of hardware to do any number of different things, different actions, different types of computations, sound, video, et cetera, et cetera. It's really amazing. Far more unbelievable than you realize if you think about it. You know, it's not like a toaster. Toaster does one thing, right? Your TV, oh, okay, it used to be pretty dumb, but now they're basically computers. But I mean, this thing on my wrist is a universal machine. So is my laptop. It's really impressive. The programming is great altogether. As many of you know, makes you a more intelligent user of computers. It's fun, it's artistic. I think of it as a form of expression. And programmers are in great demand, for sure. I'm sure Josh would agree with that. I usually do this stupid little thing of spot the differences. I'm going to skip that. And let's see. Okay, I'm done with that part. How are we doing? 11 minutes, not too bad. ChatGPT is keeping me going here. Early computers, Jacquard's Loom, Babbage's analytic machine, Apple I. This is the beginning of, most people might agree, this is the beginning of the PC revolution. Oh, yeah, I guess so. I don't know how personal the Apple I was, but there you go. It was in wood, for God's sake, right? Never seen one. I've seen someone, there was a YouTube video I saw where someone bought a replicated Apple I. Like someone took the time to buy the chips, retrace the board, produce a board, and put the chips on the board, and built their own custom Apple I. And it's, yeah, it's kind of like a modern computer, but it's still limited, right? You know, they used to use tape for, cassette tape for recording programs and reading programs. So let's jump down to Python, for why we're here today. So Python, you've seen the interactive prompt. My slides are pretty old, Python 3.4. But this is the beginning of your, your exploration of the Python programming language. This is one of the most powerful parts of the language, the interactive interpreter. Let's see here. I call it the triple chevron. I don't know if that's the right term, but I like it. I'm a Stargate fan, so I like the word chevron, so I can use that whenever I can. But you can type statements in here. Statements are programming constructs that produce results. Printing produces a result. Assigning to a variable is a statement that produces result. So a statement would be, for example, x equals 2 plus 2. 2 plus 2 is your expression, gets evaluated, and you store it into x. That's a full statement. So you can type statements right into inside the interactive interpreter and get an immediate result. And the state is remembered, so you can effectively build a program step by step in the interactive interpreter. I would not do that, but you could. But it's a great place to kind of test out ideas really quick or load up another program and make it go. Like this, right? So, a hello function, 3 lines. That's more than I would ever type in one sitting in the interactive prompt, unless you have the right sort of additional tooling, which I can show you later. Okay. So let's get into how we can make this go. Let's see here. What's our next topic? Installing Python, I briefly touched on that. IDEs and text editors. What text editor or developer environment are you using?
I'm using Atom. The book I had said like 5 times don't use idle. So now I want to know what it is.
Well, I was going to show idle, but okay. Yeah. Well, I'll show idle for a minute. I also did not really use it in my class. One reason I even wanted students to use idle is 1, it's easy, and 2, everybody has it and stuff.
Okay.
It is just the common denominator. So let's get started with playing around with some Python and get past, all of this. There's a lot of stuff here. I'm short on time. Well, let's see. Actually, we might come back to that part. I'll do idle. In my course, I actually use Jupyter notebooks as my mechanism for typing up code because the methodology of how it worked, the cells that you individually execute was really well suited for note taking in class. But you're looking at idle. And I don't know what idle stands for. I forget. Is it one of the Monty Python guys? Was his last name Idle? Yeah, I'm not that well versed with Monty Python people. So, well, good, you're not, so I don't feel so bad. Eric Idle? Is that right? But when you bring up idle, you start with the interpreter. And this is not your main programming editor. It's just the interactive interpreter. This is where you type things like print, hello world. And this statement gets executed and the result is produced. You can type expressions, not full statements, and get a result immediately.
What it stands for? Integrated Development Learning Environment.
Oh, cool. Okay, thanks. Integrated. Sounds like they really tried hard to make that work, but I like it. Thank you. So if I were to type x equal 2 plus 2, now I made this full statement. I just assigned the expressed value, the evaluated value of 2 plus 2 into x. If I type x, I can ask Python, evaluate the symbol and give me its value. It's 4. Now, there are various parts of this program here that we can talk about, which is sort of what I guess part 3 here is going to be. We have print. That's a function, a piece of reusable code that you call by name and provide data to it to make it do things for you. Print is universal pretty much across all programming languages. And in Python, it's also pretty flexible. You can provide it none to any number of bits of information, and Python will attempt to print it to the screen like it did here. 2 plus 2, oh, sorry, before I go. Hello world, in quotes, as you may guess, that's a string. It's a collection of characters. Strings are one of the fundamental data types in Python. It is what we call an immutable type, and we'll talk about that, I hope, a little later. We'll see. But you make a string, you got that string, good. You can make new strings from that string, but it is what it is when you create it. And strings in Python can be double quoted, or single quoted. Same thing. 2 plus 2, well, they're your numbers, right? You have decimal numbers or floats or integers. They interoperate mathematically in Python. They're considered pretty much similar types, although not exactly the same type. They are different types. So you can do math with like, I can say x plus 3.14159 or something like that, and I get a number out of that. So so the string hello world, the numbers, those are called literals because they are the value that they are expressed on screen as you type them, right? They are literally what they are. And X is an identifier. It's a symbol that identifies a value that you can't see. But you will ask Python to evaluate itself, to evaluate that identifier to get the value. So here I've evaluated X to get its value, and then I continued by adding that value to partial value of pi. Let's see what else we got going on here. So let's type up a simple program. Oh God, yeah, this is a lot to jam in 2 hours. So with idle, and this is pretty similar to any other text editor or developer environment. It will likely give you an interactive prompt to Python. And you will certainly have an editor to type stuff. My personal tooling preference, I know a lot of people use like Visual Code, Visual Code, right? Code Studio, how's it called? Whatever, the Microsoft thing. You use an Atom, right? I use Vim, traditional text editor of the Unix world. So my setup is slightly different. So like, for example, I have a terminal, and this is a very common way for people to operate. You might have a terminal where you can run Python in here. Doesn't have to be an idle. There you go. PT Python's going to be installed. Nice. And I have my Vim window, which I'll bring up here. And then it puts it into a tiled mode for me. And there you go. So now I have Python over here. And I'm up and running. And I can type a program on my text editor window and make things go. So I have sort of my own IDE set up, but some of you may use far more polished and modern looking applications for that. Let's see, what else can we see?
What program are you using for the REPL there?
Oh, this is PT Python.
PT Python.
Yeah. Which is really nice. It uses Jedi and various other bits to give me autocomplete and syntax highlighting and all sorts of nice things here. This improves on and I'm glad you used the word REPL, read, evaluate, print loop. REPL is the interactive prompt in Python, or really any sort of interactive prompt you might come across for programming is a read, evaluate, print loop. And in my case here, I do go into Python a lot directly. I don't like the base REPL it gives you. There's a lot of limitations with it. By installing this particular package called PT Python, it improves on it significantly, and I can get all sorts of things like, look at that, autocomplete. Right? Yeah, does that help?
Oh, yeah, thank you.
Yeah. But back to idle, which is, it's okay, plugs along. So let's type a little program. Hey, I want to sit down. Can you still see me if I sit down? Just my eyes. Hello. Okay. So I'll have to deal with just my forehead. Okay, so for typing up a program, and I'll show you using my setup, choose a setup of your own to try this with. Let's just do something simple. And what do I have for something simple here? I got my own stuff. We'll just do something basic. Right. Hello. Okay, this is as simple as you can get with a program, really. In Python, you can define new functions with, skipping ahead, aren't I? No, sorry, GPT, I have my own way of doing things, I guess. You can define functions with the def keyword. Now, this is an interesting part of the programming language that we should also talk about. I mentioned literals, values that are what you type, right? Strings, numbers, lists of values, and so forth. But there are some words that you cannot use as literals or identifiers because they are actually the language of Python in this case. Def is one of them. This is how I define a function. So if I look here, let's see, Python keywords. You might be surprised to see Python reserve. Okay, reserve, also known as reserve words. How come the Python website is never the top hit? Jeez. I used to go to this all the time. There you go. Should be in here. Here's the lexical parser. Where are you? Come on here. Okay, oh, there it is. So small that I went right past it. When we say the Python programming language, These are the keywords that make up the entire language. That's it. Those, you cannot use these words to name variables or functions or classes, things of that sort. Because they are used to create the semantic meaning of your program. I need to make a loop. I need to set true or false. I need to control the loop or make a Boolean expression. All of these are handled here. So these are called reserved words or keywords. So reserved word def, hello is the name of my function. Parentheses indicates that, well, that it's a function. It's part of the syntax of a function definition. Nothing's in there because this function takes no arguments. I have no parameter defined. So no arguments are required. And within it, I just call print. I call, that means I have parentheses and some value or values to pass into it. So I save it. Hello world.py, that is the standard extension for Python. And then we have our first program, right? We run it. Nothing happened. Why?
Because you didn't call the function hello. You didn't tell it to actually do the thing.
Exactly. Thank you. And so what we got going on here is we happily defined our new program and didn't tell it to do anything. No problem. So in Python, we do this, right? And off we go. What did I do wrong? For the newbies, if you want to answer for me. Yes, please. Hey, you're here, so I'm okay with you going first. Go ahead.
Parentheses.
Mhm.
Ooh, excuse me.
Exactly. Now, what's interesting here, Python did not make this an error. So this is an expression. It evaluated, but it didn't do anything with it. There was no full statement action on this. It's just Python said, yeah, hello's a function. And what do you want me to do with it? Just moved on, right? If I went here in the interpreter, it's more expressive about what that thing is. It tells me that hello is a function. So expressions will actually print something in the REPL, in their interactive prompt. But an expression will do nothing inside a program because that's what they are. They're just not designed to do anything. You got to make it a statement. Well, one statement here is to call it. Off we go. Hello world. Very common problem for anybody, really, in Python. It very easily will let you put in an expression and not warn you. I could type something like this, where I'm thinking like, let's make this a more complicated example. Def, hi there. Print. Hello, my name is. And we'll just give my name of me. So what was I going to do with this? I wanted to show that I could put a perfectly valid expression, but it does nothing. Like, why would I put 2 + 2 there? Like, no one would. That makes no sense. But I'm just proving. If I run this, nothing happens. Let's go to the next step of how we can use the interpreter to our benefit. We don't always have to run everything from a file that we load up. In Python, you have this concept of a namespace. A namespace is this hierarchy of groupings of names. So when you start up the interpreter or you run your program as the run it, it loads up in what I call, and I think it's also called elsewhere, the top level namespace or the main namespace. This function, dir, tells you what's defined in the current namespace. Well, we have all these double underscore thingies here that mean who knows what. They mean stuff, but not really relevant to right now. Those are called dunder names or magic names, magic methods. Dunder for double underscore, Dunder Mifflin from the office. I think that's part of the joke. But you see here that we have two names that are defined by us. Hello and hi there. No, I can just call it. Hi there. Oh, okay. So I just went ahead and made a more complicated function by specifying a parameter called name. So this, we have to provide an argument to it, the actual name. So hi there. So Bob. Hello, my name is Bob. Notice 2 + 2 was in there, did not error. It calculated 2 + 2, but that value just went off into the ether. Can you see my hands? Oh, sorry. There you go, to the ether. So be careful with that. Very easy mistake to make. Very hard to catch if you're not aware of what you're looking for. Okay, so goodness, operators, expressions. Let's talk about operators. So I'm kind of jumping all over the place because there's a lot to cover. So you can tell me if you want me to talk about something else. This is interactive, by the way. It doesn't have to be. Where's my head? It doesn't have to be just me blathering on for the next hour or so. So you guys can tell me, you know, pick up a little more in this area. You're new to this. Tell me what you'd like to know more about. Like, do you know about the Python operators? Do you know?
Put me on the spot here. Okay. How does the dir thing work?
Oh, yeah.
In mine, I'm rather than using idle, I'm using the command prompt and I'm trying to copy you. But I think I haven't defined the functions in the command prompt yet.
Yes. Okay. So in my case here, easiest way to load it in, I think it's -I. I forget. Yeah. I don't. Do I need I for this? Yeah. Yeah, I do. Yeah. I drops into interactive mode. Yeah, that's right. So when you say command line, you mean like, so you're on Linux or Windows?
Yeah, it's just the terminal.
Okay. Oh, I skipped Windows for installation of Python. Sorry about that if you're a Windows user. Fair enough.
Use the IDE install and be done with it.
The what install? I'm sorry?
The MSI install or whatever the.
Oh, straight from python.org.
Just download the executable. All of the stuff that makes having multiple versions easily swappable just simply don't work. There are lots of attempts to make it work on Windows, and none of them are actually stable and consistent because Windows doesn't like you making those kind of low-level changes like Linux allows you to do. So you can have multiple versions of Python and swap between them, and it's just a matter of playing with your prompt or your path.
Okay, good tips. Thank you. I'm just a casual Windows user, mainly for games. Although I do have Python installed on that machine, but I don't do much with it. And I think I've done exactly what Josh recommended. I downloaded the installer from python.org and just did it that way. And that's what I used to tell my students back in the day. All right, so your question was about the Python interpreter in the terminal.
Yeah, I'm trying to put my thing in there.
Okay.
It works when I put it in, but it doesn't have, I'm trying to figure out how to put the, like we just defined this in a separate file. How do I put it in the interactive?
Beautiful question.
Where did you define it? Where did you copy those things?
I just did a text file.
Okay.
So
I'm in the right directory.
okay, so you got a file. I have a file, so we'll use my file as an example here.
Okay.
If you call the Python interpreter by command, most commonly Python 3. If you call just Python, likely it will call Python 3 automatically. It's often linked or symlinked or alias to that. Just be careful if you have an old system that has Python 2 installed, it might start Python 2 and you might get confused. So usually I type Python 3 just to be safe. If I give it the name of the file, it will run it and it will quit. If I provide the command switch -I, it will run the file, that is, it will load it, it will execute every statement in there, and then drop me into the interactive repo, like so. Now I can continue working with the file that was just loaded. You don't have to actually call any functions in your file. You can just define a bunch of functions and just load it up and then go from there. Either way.
And there it goes.
There it goes. Now you can see here, I have a similar thing to that, to what I showed you in idle. So that's a great question. What else can we talk about here? Oh yeah, let's talk about, so ChatGPT said I should talk about syntax and indentation. That's a big deal. So whether you love it or hate it, I tolerate it. Python is space delimited, space indented. There are no braces like you would have in C or C++ or other languages like that. I love my braces. I come from the C world back in the day. I wish I had braces. It just looks nicer. But Python's all about indentation. And more importantly, and it's kind of hard to make this mistake nowadays, more importantly, your tab key should not produce a true tab character. It should produce at least 4 spaces, in my opinion. In the PEP 8 standard, which is Python Enhancement Proposal 8, 4 spaces per tab press is pretty much their standard idea. So any text editor worth its salt will do this automatically. You tell it you're writing a Python program, your tab key will produce 4 spaces each press. If you accidentally type in a mix of spaces and actual tab characters, Python will know and complain and warn you. Or your program will just crash. What else? Talked about variables briefly. Data types. Well, we
Can I
talked
ask a
about.
question? Can I ask a question before you get too far away from this?
Oh, please. Like I said, I'm jumping all over, and I'm not really monitoring the chat. So if someone, go ahead.
I've struggled with understanding what these dunder variables really are and how to use them.
Oh, okay.
I can see them here on the screen. I can generate them myself, but I don't really know how to use them.
That's a great question. So, in a lot of them store important information about the context of the object you're working with. So in my case here, probably one of the more common dunder names you would use is dunder name. It's just a string. It's a string that's populated for each module that is ever created. Here's an interesting bit. Every Python file you write, something.py, and you save it, it's technically not a program. It's technically not a script. Python calls it a module because it can be loaded into another Python set of code. You can tell it to import that file. But we do run code in a way that looks like a program. So we have both this duality of character to a program where it can act as a module of code you can put into another program, import foobar, or you can run it by itself. So how do you deal with that? Dunder name is one of those nice double underscored names or variables that are good for that. So I'll use that one as a quick example. I'm going to go to my text editor. Hide this thing here. And hopefully you guys can see that okay. If you can't, let me know. I'll try to make it larger. So let's say we'll make a simple function called square. Takes values A and B. That's square. That's not what square means, is it? And first off, I'm going to save it as desktop square root of pi. Sure. Okay, that's fine. It's installed. Hopefully it is. Let's see. So let's pretend we want to write a math library, something simple and goofy, like, hey, a square function, or maybe a factorial function or something like that. Who knows? We'll have fun. Well, we don't necessarily want to run it, but maybe we do want to run it in the case where we want to do some simple testing. You run the file itself, it runs a couple test cases. Otherwise, it's a loadable module. So let's have square here. So square would be a star star 2, and we'll return that. So what we have here, if you can see that okay, I'm going to make it a little larger, is a new function, a very simple function, but we demonstrate two new concepts here with relation to a function and mathematical operators. First is return. So this is a nice clean function where we take in one parameter and we return the square of it. That's it, never changes, no side effects or anything like that. Return is the mechanism by which you send data out of a function back to the person to the thing that called it. Right, this is how you connect the pipes of the different functions together to get data moving around. Double asterisk is the Python operator for exponentiation, taking some base value to some exponent. There's actually an EX, I think it's EXP. There is a built-in function called EXP for exponentiation. I just never use it. I just use the operators.
Well, I think that one's different. That
Is it?
one's e to the power.
Is it E to the power?
Yeah. So if you do exp1, it should give you what's in the
Oh, I swear there was one in the. Oh no, not EXP. You're right. It is. It's POW.
Oh,
I'm
yeah.
thinking POW.
There. Okay.
Shows you how often I use it. So, like, I don't know why I would use it. I had double asterisks. But yes, thank you. So here we have those two things. The new operator. Do you know about that double asterisk?
If I need to know an operator, I just go, which one is that again? Okay.
And this one's not really that obvious, right? It's like in some math notation, you use the caret to mean exponentiation, but the caret means something different in Python. It's a bitwise operator. All right, so now what? Let's continue on. Save that. Stop. Okay, let's do factorial. You know what a factorial is? Anybody who doesn't know what a factorial is, I should start with maybe. Right. So we want to take some number times n minus 1 times n minus 2, n minus 3, all the way down to 1. Take fact of a, and we can say 4, and this would be a great opportunity to talk about loops. We can use while loops, you can use for loops, but for loops are great. And we'll talk about why. For I in range of, let's say, you do it two ways. Let's start with A down to what? Let's start with this for a minute. And I say already print I. So I have a problem here. I'm like, how does this code work? No, I could just save it and test it out, but you know what? I have the interactive interpreter at the bottom there. And as we talked about before, I have PT Python, so I can get away with typing multiple lines in the prompt and not feel dirty about it. So I'm going to go ahead and type 4. Let's say A is equal to 6. For I in range of A. 1, 2, 3, 4. Print I. Huh. Interesting. Now I got to figure out how this loop worked. So what we're looking at here is a for loop that's counting down from 0 to 5. Or sorry, counting up. Jesus. So it's counting up from 0 to 5. So are you familiar with the range?
It starts, it's like from 1 point to 1 point, typically. Since you didn't specify one and it started at 0, I assume its default is starting at 0.
Exactly. And you can flip it too. You can decrement. You can also skip values. or steps, as they call it. So in this case here, we are starting at 0 and counting up to 5, which is 6 values. But just for fun, I want to do my factorial by counting down, because most people, when they think of factorial, we think of starting with n, and then times n minus 1 times n minus 2. Feels better that way. So we want to start with a, comma, 0. Well, let's try it out. I'm going to copy and paste, which thankfully this prompt lets me do, but it does nothing. Why doesn't he probably know? Why didn't it do anything? My loop should have printed I, series of values, but I got nothing out of it. What I typed was technically valid. Certainly was not a syntax error, was it?
A logic error, because A is the start. If somebody else wants to talk, by the way, I'm not the only newbie here. Come on, guys.
Well, okay, I'll give you a hint. We want to count down, but range is typically a count up function. So I'm telling it to count down, but not really. So the third optional argument here is the step. So by default, step is always 1.
Okay.
It's never there because its default is 1. Or I believe it's also step equals 1. I think this will also work. No, it does not. Okay, well, it shows you what I know. But if I just do this, it still doesn't work because it's still not fixing the problem. We want to decrement. It's basically saying, how do I get from my start value to the next value? And the default is add 1. Well, I can't add 1 to 6 to get down to 5. So specify -1, which means 6 minus 1 gets us to 5. 5 minus 1 gets us to 4. And so on. There we go. And notice it didn't give me 0 this time. Started at 6, but ended at 1. Still 6 values. No, it isn't. 6 values, yes. 6 values. But the way it counted is different. The stop value in a range is never included. If you need to include it, you got to go one past to where you want to be. So now we have the basis of our factorial function here. So let's, a to 0 minus 1. So a common mistake might be to think, well, I want to go from a, which might be 6 or 7, whatever, and stop at 1. You'll be 1 number short. Always go one past where you want to be for stop. And there's a that's not even done. Okay, so let's keep going. So to make this a factorial, so we want to start with fact equals 1. Remember, it's a multiplicative aggregation. So fact equals fact times I. And then at the end, return fact. I think I did this right without thinking too hard about it. Let's load it up and see. Oh, that's the wrong file. I called it square. That's not what it should be. Don't call it math.py, by the way. It can cause problems if you store it in just the wrong place. And on the Mac in the documents folder, it's a default location. It's a default search location for modules. So if I were to save a file called math.py on the Mac in your documents folder, it's going to load that instead of the real math module, and it will cause idle to crash. Very common problem I've seen with students. All right, so square, spell it. Okay, looks good. Should be 720. There we go. So I have my little math library. But going back to your original question, this Dunder name, like what do I do with it? Well, each one is different. Each one has many different purposes. But the most common one I end up using is what I call the namespace check. Am I loading this file as a module? That is, I don't want to run it. I just need the contents. Or as a program, I need it to run. So this is a very common check. If Dunder name is equal to string Dunder main, there we go, then we can say call square of 6 and then fact of 6 or something like that. So let's write this here. Print testing our this is stupid testing, but it's testing nonetheless, right? It's actually doing something. Well, I'll call this X, and we'll say X is this and X is that. And don't forget, okay, I guess maybe it's not a full statement. Still need to print it. Should print your function calls. Yeah, I guess functions are technical expressions in that case. Except for print, because print prints out text. All right, so let's say we run this now. Testing our math library. Now, okay, now what is the point of this? Now let's look at it from a different perspective. I am going to change my directory, because this will facilitate what I'm trying to do here. I'm going to load up Square. Okay, ran my test library, blah, 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 we're great. Well, let's pretend I'm writing a brand new program, or maybe I'm just goofing around in here. Let's start fresh, Python 3. If I type fact, not defined, neither is square. Okay, fine. So I'm going to import my module that I badly named. And the blue is horrible. I don't know if you can see it. Import square. Now, I started the interpreter in a directory that it could find my file called square.py, and it loaded it up. So square, what is it? Notice now it calls it a module, and it points to the file that I had edited, I am editing, but it did not run it. Because now if you look at the dunder name inside this thing, it says it's square. So in other words, this file up here that we typed up, if I run it as a program, its name becomes dunder main. If I load it as a module, its name becomes square. That is usually the name of the file that contains it. That is the context switching, that modality of, are you running a program or loading a module? And this simple if statement does the work. So that's one good use of a dunder name. We're just reading the value. You don't change it. I think it might be a read-only value. I never tried changing it. There are other ways to get a different name for your modules. We can talk about importing later. So any questions about that? We'll bring up more dunder names that are pretty cool to look at, but this is one very common one.
Yeah, that helps some.
Okay, good. And we'll continue on with a few more. But we're looking at now a couple new things here. A module, a new concept, and an if statement. Now we're talking about conditionals and all sorts of branching operators. So Python has one main type of construct for decision making, the if statement. It can have three variations: if, elif with another condition, and else. Or the way I put it, it's a single decision. You can have a two-way decision like if else, or a multiple-way decision like if, elif, 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 and then an else, optional. So a variety of different combinations of if statement clauses to do what you got to do. Python doesn't have, if you are fans of switch statements, for example, from C, like I am, Python doesn't have it. You can mimic a switch statement if you know what that is and desire it using a dictionary. It's not a perfect analog to it, but it's pretty good. Another form of decision making of a sort, I guess, and I haven't really used this, is a new feature called structural pattern matching. Kind of looks like a switch statement, but it isn't. I haven't really used it. I'm looking for a reason to use it. Probably have missed a few opportunities to use it, but it's pretty cool from what I read. But that said, if statements are the thing. So we're making a choice here. We are saying if this variable is equal to this value, we do this. Equality in Python is double equals. Single equals will be a syntax error and fail out. Some of you, again, from other languages, C-based languages in particular, might be tempted to assign a value inside a variable, inside a conditional, kind of like this. Well, that's probably a bad, probably don't have a good example of this, but let's say if X is equal to 5, return A. This would fail, right? You can't have a single equal sign here. But you could do something where you could have, I use this only once or twice. X equals, I'm going to use the freaking walrus operator. I was not prepared for this particular example. But the walrus operator, hello, walrus. Here we go. Okay, so what's it got?
What you might do, you could check if X is in a range. You could do like 2 less than or equals 2, and then put the X walrus equals 5 in parentheses. And then you should be able to use X within the if statement, if I'm not mistaken.
So which example? You saw it on screen,
like-
or what do you want to
Oh,
do?
no, just I think it should work. If you do like if 2 is less than or equal to, and then the X equals walrus, that thing in parentheses.
Yep. There you go. Thank you. That's great.
I think it will.
Let's try it out. Well, we don't have X defined in here, but let's define it. If 2 is less than X is, wait a minute. Yeah, it's assigning X to 5 to X rather. Stay. Oh, yeah, right. Print X. Yeah, it's silly and dumb. Okay, great. And let's flip this around. Maybe doesn't really matter if it's greater than or less than. Okay. This is new character here. What is that? See that? Yeah. So what does that do? First off, I didn't even set X. I did over here though. So I did get set. So what X? Nope. Why did X get set? X equals.
Beside the
Oh, because I didn't actually run my program. That's why. Yeah. And right, it's not a function. That's what I meant to do. All right, if I run this, it's going to say A is not defined. I'm going to take a 10, 15. Hey. So you can see why I probably don't use this often, because it's kind of confusing to look at. But it's called a walrus operator because the colon is the eyes of the walrus, and equal signs is the tusks of the walrus. And what this says, and this is for people in C who like this weird anti-pattern, which I've been guilty of in the past, of where you do an assignment inside a conditional. And I'm so deconditioned from it that I can't remember how to do it. So thank you for helping me remember how to do it. This is saying, let's, and the reasons maybe why you want to do this, usually at the expense of clarity. I need X to be some value, and I need X to be compared to 2. But I also need X to be usable somewhere down here with some expressed value that's been updated. So instead of saying X greater than 2, I need to have X assigned to a new value, and that's where 5 plus A comes from. We assign it to X, and then we can do a greater than 2 comparison. And in other words, allows us to put an assignment inside a conditional.
Where I have found that useful is with while loops, where you'll have to like initialize whatever your condition variable is.
Yeah.
And then you say if you're doing like an input loop, you have to get the input, do your checks, to make sure you're continuing, and then get the input again at the bottom. You can just put however you're setting that up inside the while loop and skip the initialization.
That's a great point, yeah, because normally you would have to put that initialization outside of the loop, and this way you just kind of put it together in just one line. Yep. It's useful. It's just not one of those things I use very often. But you use it once or twice yourself, it sounds like. Okay, so moving on. What else can we talk about? So yeah, with making decisions, we have various operators that give us a Boolean result. Double equals, equality testing. Greater than, well, it is what I just said. Less than equal to, greater than equal to, are your, and negation, not, and, or your conditional operators, and you have your Boolean operators. So you can say things like A greater than 10 and B not equal to, that's inequality, 15, something like that. Oh, how'd that work? Actually have a B defined? Oh, aha! Why did it do that? Well, anyway, before I get to that. So the nice thing about these Boolean and conditional expressions like this, relational expressions and operators, is you can combine them, right? I can see if A is greater than 10, and I can see if B is not equal to 15 and connect them using a Boolean AND. Both of these have to be true in order to return a true. And otherwise it returns a false, as it did here. However, and exclamation equals is inequality. B is not equal to 15. So in the haste of my example here, I typed B, which is not defined. I showed you here, like, how did it express this thing here where B doesn't even exist? Anybody know why this didn't fail with a syntax error?
Short circuiting.
There's a great movie from the 80s that was named this.
Short circuit.
There you go.
Yeah.
That's right.
It's been a while.
In a while. Johnny Five is alive. And so this is called short circuiting. And this is another neat feature of logic and just sort of programming shorthand. This never failed, B not equal to 15, because it never got a chance to be evaluated. Why? Well, a Boolean AND requires two things to be true. If the very first thing you're evaluating is false, it has no reason to continue. Logically, it's never going to be true. So just give up. It short circuits and it just returns false, which is another great way to never see an error occur, right? Like, then no B, B wasn't defined. So those are your basic operators. And I don't know if they're even in this page here, maybe. Oh, perfect. Nice. Okay. What other operators can we talk about here? So I brought up on the web page here, not equals for inequality, equality, greater than less than, Walrus operator, tilde, caret. These are bitwise operators for manipulating single bits in values, which are beyond what we want to talk about today, bit shifting. We have the mysterious AND operator, and at operator. And maybe used that before.
Matrix multiplication that only seems to work with NumPy arrays.
It's my understanding, yeah.
Yeah, it won't work with any built-in data types. It's weird.
But using the magic of dunder names, you could have your special object that you made use the add operator. But yes, I only know it to be used in NumPy. In fact, there are a few things in Python that were created solely for support of external third-party packages, like the ellipsis operator, ellipsis object, triple dots.
I didn't know that.
Yeah,
That's cool.
it's some places you can use it, and honestly, I never really used it. I may have used it once, but it's there. But it's used for, I think maybe I forget exactly who uses it. But yeah, things like that that exist are kind of arcane, but usable by something. But we have other math operators that do matter and a little more pertinent to our discussion. So we have, of course, our basic arithmetic. We have division. So the forward slash, if you're not familiar with that notation, of course. Exponentiation, double asterisks, double forward slash. Is that familiar to anybody? What did,
Oh, you showed me that like 2 days ago.
You're right about it, sort of.
It returns the division minus whatever's left over.
oh,
Like the opposite of
yeah.
the modulo kind of. Sorry, that was very mumblish.
No, that's a great way to put it. Yeah, I call it, like floor division, integer division. If you see down here, if I say import pi, import math, what am I doing? Math.pi, value of pi, and I floor divide pi by, I don't know, 2. Comes out to be 1. But math.pi divided by 2 should be this. So floor division, yeah, thank you, great job. It just drops you down to the integer value of the division and drops off any decimal part of it. And similar to that, modulo is the remainder. So math.pi mod 2. Did I do that right? Is that the remainder? Is that the remainder? Must be. Doesn't seem right. Yeah. Oh, right. It's yeah. Let's do something more obvious. 3 divided by 2 is 1.5. 3 mod 2. You have a remainder of 1. I guess I'm not used to a fractional remainder. Yeah.
That's fair.
Yeah. Kind of hard to talk about it, I guess. But like, you have 1 remainder out of the division of 3 divided by 2. So, and 3 floor division 2 is 1. I don't know, not the best examples, but nonetheless, do what you will with the remainder from a division and the floor of a division. You know, we have that if you want. Delimiters. This is an interesting. Oh yeah, did you know there's a complex number type? Anybody here like complex numbers, imaginary numbers? Another data type I never use. Not sure why it exists. But you can have a complex a numeric type along with your ints and your floats. So how do you know what is what in Python, by the way? Let's jump back a little bit to the beginning, since this whole thing is all about doing my own thing instead of following an actual outline. See, we have X. So if I ask Python, evaluate X, it gives me 15. You can intuitively tell, okay, well, it's probably an integer based on how it looks. One of the nice built-in functions, and by built-in, I mean I don't have to import anything. It's ready to go. Type of X. Type is one of those functions. If you call the type function and give it a value, could be a literal, could be an identifier, that is a variable, give it something, it will tell you what it is. It's an int. It gives you some additional cruft around it. I mean, it's useful cruft. Class, int. And interestingly enough, I also brought in something else earlier, math. What is math? It's a module. All right, what's pi? It's a float. So the type system, as you call it in Python, is based on what are called classes. Python is through and through an object-oriented programming language. Everything is designed around the idea of classes and creating objects from those classes. Who knows if we'll have time to talk about classes, but it would be nice if we could. So those are data types in Python for the most part. Python is not a strongly typed language, is the right term? Strongly typed, I always mess that up. Strictly typed. They're very well typed. It's a lazily typed language. So in the end, what happens with Python is any object you give an operator, 2 plus math.pi. 2 is an integer. Pi is a float. They're two different types. How do they work? Well, first off, the power of under names. Well, hopefully get to that at some point. But math.pi and 2 are compatible because of what's called duck typing. If it walks like a duck and talks like a duck, it must be a duck. So 2 and math.pi both talk like numbers. Which number? An integer or float? Well, it's going to pick the one that is most relevant here, and that's going to be the float. So 2 talks enough like a float to be a float. So it gets added to math.pi. Duck typing is a powerful and infuriating feature of Python. If you prefer your types to be clear and distinct and declared, sorry, that's not Python. So you could do type hinting, and we're not going to talk about that, but that's probably the closest you're going to get. It calls them delimiters. They are delimiters, but there is a neat little infix operator thing here, along with our other operators. It helps sort of bring together common arithmetic operations. Consider, for example, let's clear this out. You do this very often in Python, or any language. Let's say I is equal to 0. And you want to increment I to itself. You would say I is equal to I plus 1. Great. Run it again and again and again. But that's a very, very common thing, to take the variable itself and add, some expression to it. Plus 1 is a very common one. You can simplify that with a plus equal infix operator. So it's saying, take I and add to it whatever's on the right-hand side. In this case, 1. It could be any arbitrary expression you need. 1 is perfectly fine here. And it'll do the same. So I could write a for loop, sorry, a while loop, while, let's set I is less than 20. 1, 2, 3, 4. I plus equal to 1. Let's see. I did this wrong, or whatever. I'll print I after incrementing. 10, 20. What's that? Oh, geez. This I is equal to 0. That's not what I meant to do. Print I. And we want to add 1. There we go. So this while loop here has the condition of while I is less than 20. So this loop will continue until I becomes 20. So here we are. We got a couple new things I just brought up here. Finished off the operators. Any questions on the infix one? Is that you've seen that? Like the plus equals? And you can use any of the other arithmetic operators here as well. Same thing. I multiplied by some value on the right. So we have that. The while loop has a condition in it. The condition is important in a while loop. You can easily become stuck in an infinite loop if your condition never evaluates to false. So make sure it's a condition that does evaluate the false. Python will not catch an infinite loop for you. You won't know what that means, right? So you have to just be aware if your program is never ending in a decent amount of time. So a while loop requires a condition. It is a precondition loop, not a post-condition, meaning your loop can run 0 or more times. It's very possible for your while loop to never run. It's possible for the condition to evaluate the false immediately, and the loop never goes. A post-condition loop would be something you would see in, well, C, a do while or a do until loop. It's a very common one. So I can show you, I actually have a slide for that. If I can find my stuff. Where's my stuff? Loops and rules. So, oh, yeah. I have these. Oh, there you go. That's pretty handy. All right, so if you wanted your while loop to always run at least once, and then you check your condition and end, you can do something like this. While some always true value, and guess what? True is a perfectly good true value. Some people might use 1. That's very C of you, but it's okay. Here's an infix operator, right? Factorial, the multiplicative counter. I decrement this counter by 1. But of importance here is this special condition at the bottom of the loop, where eventually when my counter is decremented to 0, I check. Well, I'm always checking. But once it actually hits 0, I initiate a new keyword here called break. Break is great. Break is a way of escaping loops, for loops and while loops. And in loops, you have my memory is serving me 3 different ways to control what you can do during an iteration of a loop. 2 ways will break you out of the loop: break and return, assuming you're in functions, in a function. That will exit the loop. Break will leave the loop and continue on with the code of your function or whatever bodied code you're in. Return, presuming you're inside a function, of course, leaves the loop immediately. Same deal, loop is done, but takes you back to where you were called. But break is very common. So in this case, leaves the loop and we continue on to print. So this is a post-test loop where we don't check the condition at the top. In fact, the while loop is not even used for checking a condition. That's a very common pattern. Book I used to use called this loop and a half. I never, it's just you put your condition in the middle. I don't know if that really matters. What else? But what does it look like in C? Here it is. This is actually, let me pick a better example. Way back up here, I think it is. Yep. Nope, not it. Where are you? Actually, this is a great example of the difference between a while loop and a for loop. So the way I regard for loops is this. For loops are a counting loop, or some people might call them a for each loop, depending on the language you're using. For loops are not like in C, where you provide sort of an expressed range and conditions to work within. The for loop in Python counts objects. This is why you'll always see this pattern of using range. You can use any sort of countable object in Python. It could be an iterator, generator, a list. A range is a, let's get this too mixed up. Is it an iterator or generator? Iterator? I'll go with that. Someone's nodding, I don't know. But either way, a range doesn't make the entire range. If I say a range of 1 million, range does not actually make a list of 1 million numbers. What it does, it algorithmically generates or yields the next value starting at 0, let's say, up to 1 million over time. So each time I talk to the range object, they say, give me the next number in the range. Okay, it's 2, 3, 4. And my loop can operate on. So it never actually generates the entire list unless you're crazy enough to coerce it into a list type, in which case it makes the list. So for loops are a specialization of while loops. I can do the same exact thing in a while loop that I can do in a for loop. But a for loop is limited, of course, can't do everything a while loop can do. So you can see these 2 equivalent loops. Let's see, what else here? Common number structures. I used to cover like different patterns of loop usage, interactive loops, sentinel loops. File loops are great. We don't have time for file loops, but files are great. I always skip the computing Booleans. Where is it? Anyway, we'll stick with this example. Roughly speaking, this is what it looks like in C. This is, oh, I read this as infinite loop. Okay. Forgot my own content. This is correct. I skipped it because I thought it was infinite, but it's not. So this is what the C language would call a post-test loop. It's built into the language. So you have a do and you have a while. Your conditions checked at the bottom. But this is not a course in C, but my point being, this is what we talked about a second ago, to mimic that same functionality. It's not built in. You have to sort of abuse the while loop for it. Here's a little comic for a little break.
Is that pattern considered good practice? The while true and then breaks?
I don't particularly, I use it and it's not my favorite pattern.
Okay, that's about how I feel about it.
Yeah,
I always feel a little dirty, but sometimes it just makes the most sense.
it does. Yeah, exactly. Otherwise, you have to, yeah, you have to ensure, because you need your loop to run at least once. So you got to make sure your conditions are set correctly. Yeah, I'm with you on that. So this comic here is pointing out the differences between a while loop and a do until or do while loop. That is a precondition and a post condition. The precondition is checking whether you've gone over the cliff. The post condition checks that you've gone over the cliff after you've gone over the cliff, et cetera, et cetera. So, loop and a half. Okay, that's for that. Okay, so we were covering a lot. Covered operators. What else is ChatGPT finish? We covered functions to some degree, parameters, default values. Oh, so much of that. A little bit with modules. We haven't even talked about lists and tuples and stuff like that. Let's do that right now. Some data structures. Okay, so let's talk about, oh, unless before I continue, do you have anything in particular to touch on, cover, go into some more depth, or should I continue on with lists and sets and whatnot?
Depends on the others. One thing I found really helpful when I first started getting started is I got really excited once I got the input function.
Oh, input. Yes.
I don't know if anyone else wants to learn about it. I kind of got the basics of it, but I don't know who else is here.
Input's great. In fact, I got lots of example. Let's see. That's a good example of input stuff. Let's try the interactive loop. This might do it. Sure, open it. I have no idea if it's gonna work. I did not check to see if Jupyter was running on this machine. No, you're welcome. Thank you. That was quick. I have it installed. Jupyter Lab. Boo. Okay. Next install. Oh, here we go. Here we go. Here's something for you Python people, right? Very often you will want to install something that is not built into Python. Python has a very rich standard library. And that means batteries are included. Lots of things you can do are already there, ready to go, but there are a lot of things that are not included. Like good numerical processing, data science stuff, specialized other stuff, this or that. Huge ecosystem. So what we need to consider is how do we get stuff onto the system to extend your Python installation? The pip command is most common. I'm not going to use pip, but pretend I am. I'm going to use pip x. I recently got myself to use it. I've known about it for years and completely disregarded it until I used it. And then I'm like, oh, this is great.
Pip x.
Pip x. What it does, it installs. Is this the right one? I forget what it is. That might be it. Okay. So a lot of times programs you install through pip often have commands that you can run from the terminal. Things like Jupyter Lab. Others I can't remember, even though I use them every day. There's lots of examples. but they can get installed in areas and clutter up and get confused. And Python is a beast, particularly if you have multiple versions installed. Very easy to get things into a complete mess, which is why I recommended ASDF at the beginning. That way you can segment your installations of Python. So what pipex does, it downloads and installs Python packages that have executable commands to them into a neat little sequestered area, so that all the if you know what a virtual environment is, it doesn't mean virtual environments. I'm trying to say virtual environment without saying virtual environment, but it's basically compartmentalizing all of it in a nice, neat way. So then I should be able to type brew uninstall what I had before. It was brew. I have installed it. Oh, maybe. Is that it? Okay. Here we go. So now Jupyter Lab. No. Jupyter. Here we go. Good deal. Okay. This. Okay. Success. Let's see here. Open from path. File browser. There's no file browser. Desktop. Oh, shoot. Does not know what a Mac alias is. Let's go in here. It's in the documents. It's in here. Lectures. No, but lectures. Loops and booleans. Lecture loops. Interactive. Holy moly, that's getting cramped. Oh, let's get this to the side. Put it out. Put it out. There we go. Okay. Hopefully that's viewable. So these are notes from my course. And let me see, this being an interactive loop means there should be the input function. Now, the book I used, the guy was clearly a Java programmer at some point. So a lot of what he did was sort of Java E. I tried to improve on it over the years, but I still fundamentally kept his examples. So here are a good use of all sorts of concepts we've talked about so far, except maybe print string formatting. So let's break this down. And if you can't see it, let me make it, can I make it larger? Oh, there we go. Good. Oh, but gosh, you can see extra spaces. And get yourself a nice editor that will show you spaces, syntax errors, styling problems. That's something I can't even begin to cover today. So let's talk about input. So input is this neat little function. It's built into Python and it reads input from the keyboard. I don't use it very often except for demos like this, but if you're making a program that reads interactive prompts from people, perfectly valid thing to use. So in our case, we want to create this little accumulator program that reads in numbers and produces a simple average. So we need things like a sum of the numbers entered and a count of the numbers entered. So our function here is this, broken down as such. So we have defined main, very common and traditional name for a function. We have three variables that are assigned. This weird thing called more data, which is set to yes. We have a variable called sum underscore equals 0.0. Should you ask me why I used an underscore?
Yeah, I was gonna. So because it's a reserved word.
Not reserved.
I mean, it's a function.
It is a function, yeah.
How is that on the practice aside of using the underscore versus a synonym,
The synonym in which way?
like a different variable name.
Synonym, just rename it. Well, you could do that. Instead of calling it sum, like, I don't know, what's another way to say sum? Total? But like, you wanted to use sum and I wanted to use sum, like, how do you get around it? Okay. So I could have said this and this would have been fine. But notice it highlighted it because it knows it's a built-in function. Sum is a function you can call and give it numbers because it's a sum. No surprise. If I did this, I override sum within the local scope of this function. So sum would not be usable as it was originally intended if I did this. It would be a number now. So the underscore is a common practice to disambiguate, to make sure it's clear. It's not a requirement. It's not a particular feature. It's just something, a practice you would get into. If you know sum is something or any other name is something you don't want to overwrite, put an underscore at the end. You got a slightly different name. Or pick a synonym, like you said. So that's why that underscore is there. I just did not want to overwrite that function. So in our little example here, so we initialize 3 variables. We have a while loop, and then we're going to loop over this and add a bunch of numbers together. A while loop has a condition. While more data equals y. It's really dumb, but the whole point is we are indexing a string. One of the beautiful features of a string is that it's a sequence. I could use a string in a loop as a countable object to run the loop. I could index it. Oh God, there's so much to that. I need to cover. You can slice, you can dice, you can do all sorts of cool things with a string and a list. But in this case, I'm taking the string more data and I'm indexing it at 0. That is the first position in that string. And I'm just checking to see what that character is. When you index a string, you get the character at that position. So what's at more data 0? By default, it's going to be yes, or it's going to be y. It's a little stupid little shorthand. Is more data equal to y? Or, I can say yup and it'd still work, right? Next step, input. So what input does, it takes in a string. You type in something, press enter, it's fed in and stored as some value if you do it that way, or you can print it. So jumping to yet another prompt. Where's my, it's behind here. Let's test it out briefly here. Input, type a number, colon, space. So the way input works is you provided a prompt. Type a number, colon, space. Press enter. There you go. There's your prompt. Okay, I typed the number 42. And it returns 42. But you should notice that it's got quotes. Well, just by looking at this, we know it's a string. Now I'll tell you, save time here. Input always returns a string of characters that you typed in. So how do you get from what you typed in as strings into something more useful? Well, I loathe to use it or mention it, but you can use the eval function. That's as much as I'm going to say. But I would not use the eval function here. That is it's a perfectly valid function. It has some really cool uses if you know what you're doing. And I had really no choice but to teach people for years to use it until I started changing it near the end. And the way to do it, in fact, I think I have a whole notebook I wrote on why you shouldn't use eval. But the idea here is we should take, okay, let's try this one. What if I said, please type in 2 numbers. Uh-oh, hello. What am I doing? I have a much better interpreter right here. Let's just do this. So by the way, this being Jupyter, it's still Python. it is just the same in the fundamental aspect of that of idle and the Python interpreter, and it runs Python code. So I'm going to go down here. In fact, I'm going to go down after this one. So if I said, hey, let's say X and Y, input, enter two numbers. What do? Okay, I'm going to enter 42 and 24. Blows up on you. Congratulations, I just showed you an exception. Exceptions are a fundamental error reporting mechanism of Python. It allows you to recover your program, hopefully gracefully, so that it can continue on, or to just end ungracefully so that you have it recorded somewhere, maybe in a log or whatever. But it's there. It's a facility to programmatically manipulate if you want, and you won't have time to talk about it beyond that.
One note on exceptions. I do find it generally more helpful, and it might seem a little counterintuitive to not capture exceptions and to let them happen so that you have visibility on them and you have less of an opportunity for hiding them on yourself.
Absolutely right. And I do have one, and I'm hoping we're on the same page with this, but oh, shoot, we'll get to that in a minute. Let me finish the input thing. All right, so like one quick example. We want to get two numbers out of this. Well, it's a string, and one of the things you can do with strings is split them. So usually I call this like, I can't call it input, right? But I could call it input underscore, and then print. Here's a cool thing about objects. If you're not familiar with object-oriented programming is the idea of encapsulating data with relevant action on that data into one thing. And so that means, for example, if I have widget X should only do these things that widget X can do. And widget X will have properties, that is values that describe it, that only matter for widget X. In the case of strings have properties. Those properties already have characters and positions. We also have actions. And those actions, what are those actions? Help. If you haven't used the help function, please do. Right? It tells you everything. So I want to know what strings are about. And I can skip all those dunder methods and going back to that question about dunder names. Oh, gosh. You can read up on them and learn how to manipulate them. But there's a lot of cool stuff here. But you'll find out with strings, for example, I could manipulate strings to do things. I could capitalize them, center them, count certain substrings in them, all sorts of actions. But nowhere in here will you actually see the modification of a string itself. Every action produces a new string or a relevant value about the string, like a count, like a number. The point being that a string is immutable. You cannot change the contents of a string. You can only create a new string with any changes you want to apply. So if I want to capitalize an entire string, string A is left alone, but string B will be made with all the characters capitalized.
Okay.
So that's an important property of strings, as well a property of integers, floats, complex, and tuples. They cannot be changed once they've been created. And that's great for things like dictionaries, which maybe we can touch on before we end here. So anyway, let's get back to this quick example. I want to take this input and take input and split. That's one of the features, methods of the string object. 42, 24. Oh, well, here's a problem. it included the comma in here, which is not what we wanted. All right, no big deal. This is not a great example because there's a lot that can go wrong. So with split, the default operation is to split on white space. That is spaces, tabs, carriage returns, whatever, etc. So I'm going to type 42 space 24, press enter, and it gives me a list of the string split in two. Because what I typed, and if it wasn't obvious, let's type it, do it here, print input underscore, actually, 42 and 4. Aha. So what I showed you here is the exact input I typed. I typed the characters 42 space 24. I told that string object, hey, split and make a new string from it. It's not obvious, but this whole thing made a new string. This string here is left alone. And I immediately printed it. Now, not a string, sorry, a list of strings. So this list here is the result of that. If it couldn't split it, it would just be a list with one string in it. It would be the original string you have. So that's one thing you can do. Input is flexible to a certain degree, but all the work has to be on you. You take that input and do it with it what you want appropriately. Does that help answer that question? Okay, what else can we talk about? Other data types. Let's bring up. Got 2 minutes left here. Let's go to sequences briefly. Notebooks. Counters. Yes, we have string methods. Slicing, indexing. Let's do slicing. It covers a lot of stuff right here. Nice. Okay. Let's say we have a string that's called greet. Hello, Bob. Now, I said with strings you can index. I can index hello, Bob, starting from 0 all the way to 8, because there are 9 positions in the string. Bless you. But you can also index in reverse.
Oh, okay.
I can index position -1 or position -9. If I say index greet, -1 and comma greet -9. The comma is a great way to put 2 expressions on the same line. And, oopsie. Let's do this first. I get B, I get H. -9 for capital H and hello, and -1 lowercase b and Bob. So indexing is great, but again, it just returns a single character. The next step, and you learned about slicing?
Learned about split, but not slicing.
Okay, slicing is sort of like range. You have a start and a stop and an optional step. So for example, if I wanted to slice greet from position 1 to 5, instead of hello, Bob, I get hello. So
That's everything.
cuts everything out from it. It makes a new string, gives me from 1 to 5. Stops, but does not include the end position. So 5 is not included. So I get hello right here. Oh, it's not a 5. Okay. Let's finish this up. And
You said you could step, you could change the step.
yeah, this one. Here we go.
Okay.
Yep.
Oh,
Yeah, so you can step with a slice, and that means it cuts out some interleaving characters. All sorts of cool. You can have implicit slicing where if you leave off the start, it assumes you mean 0. If I leave off the end, it assumes you mean the end. If you leave off start, stops, and steps, but include like 2 colons, it returns the whole string. Someone said it returns a new string. I don't think it copies. I think it returns the same object. Because it's immutable, so why would it make a new string? You can't change it anyway. This is just going to be a copy of it. Yeah, see. Oh, here you go. I'll prove it to myself. They are the same value. They are the same object. So I used double equals to do value equality. Is the implicit, I don't know what you call it, but the implicit slicing of this string, the copy it gives me, the same as all of greet? Well, yes. The thing it gave me back was indeed hello, Bob. Is it the same object? The is keyword is a great object identity keyword. It says, is widget A this widget on this end? Yes or no. In this case, the string object it returns is indeed the same object in here. You might think that's obvious because it has the same value, but two objects might have the same value, but they're different objects. Value is not the same as identity. What else? So steps and so on. And the crazy thing is you can do negative slicing. You can use the none keyword in special areas to deal with implicit ends. I can reverse strings using slicing. Like this, for example. This will reverse the string.
Well, the audio is obviously back now.
What? Oh, so now you responded. Okay.
Yeah, I can hear you now. You went dead silent for a bit.
Well, that's fine. Well, as you know, I mean, this was a 15-week course, so obviously
Yeah.
there's a lot to cover here.
And we can do it to be continued for sure.
That's fine with me, if it's fine with people. I mean, I should have gone a little more organized if that were the case, but it's,
I think that it would be good to actually kind of formalize these sessions and run them like once every 6 months or so.
I mean, I have a class. I mean, all we have to do
Right.
is just take my notes and actually build a more.
But
coherent
I think it would be helpful for people to know like what to expect out of the talk.
I have a
Kind of give
syllabus.
a mini syllabus.
Yeah, I have all that. It was just have to condense
Yeah.
it. I mean, probably don't want to run a 15-week session, but
No. I'm thinking like maybe 2 sessions. So every 6 months we take 2 months. So
I see what you mean. That'd be nice. I wonder if we could do, I mean, this is perfectly fine. I don't think it needs to be like a lecture hall or anything.
no.
But for the most part, yeah, if it's something you want to do, we can formalize it. We can talk about it next week.
I think we always get from my experience, we get some of the best turnouts when we do these.
You know, way back when we first started the group, we had workshops.
Yep. And I've heard people asking about those, but like our experience has been, it's hard to get people to actually show up.
Oh, it's always hard to get people to show up, you know, particularly on a
Yeah.
weekday evening, right? It's,
Yeah.
Yeah, I mean, it's part of the problem of groups in general, where you just
Yep.
have to get people out there. But, you know, you try.
Yeah.
Anyways,
But yeah, we'll noodle on that a little bit. I think that it's something worth thinking about.
okay. But anyways, for those of you that joined and stayed, thank you. Those who left, thank you, I guess.
Thank you.
Thank you for showing up. Thank you too for showing up. If you guys want to show up next week,
Yep.
Josh, I'm sure you'll be there by then, right?
I'll be there.